This is the video for question number 2, and we're looking at the quantum mechanical number, and it determines the allowed energies an electron can have and how likely it is to find the electron in different areas around the nucleus. And the first number under that is the shell, and that's the energy level, and the shell equals the energy level, which is n, and that's the period number. So if you were in period number 2, then you would have 2 energy levels. Two energy levels, and this relates to the quantum, or the periodic table relates to the quantum numbers because it gives the electrons a unique orientation. And for the next one, subshell, this tells the shape of where electrons can be, and so if there's one sublevel, then this means that it'll be 1s, and there'll be one orbital in it, and it can have a maximum of 2 electrons in it. And for S, for the shape of it, it's a sphere, and that shows where the electrons can be. For P, the shape would be 2 teardrops, and kind of like, here, I'll draw it really quick. The shape would be kind of like that. And if you had a principal energy level of 2, there would be 2 sublevels, and so the first one would be 2s, and under that there's only 1 orbital. But for 2p, there'd be 3 orbitals and a maximum number of 8 electrons. And it relates to this because it gives it a unique placement. And for the next one, for D, it's kind of like a donut shape. It's a weird shape, but that tells you where the electrons can also be. And if there's if it has a principal energy level of n equals 3, the number of sublevels would be 3, and then the first one would be 3s and 1 orbital, 3p and 3 orbitals, and 3d and 5 orbitals, and with a maximum of 18 electrons. This relates to quantum because it tells where all the electrons can be, and it gives it kind of like an address of what they can be and what will happen to them. For the last one, for orbitals, it's the orientation, and it determines what axis it can be on, and then it tells whether it can be on the if it's on the x, z, or y axis. And orbitals exist separately, and you can figure out how many valence electrons are in the outermost orbital by looking at the row number. So if it's under 3a, then I'll have 3 valence electrons, and by looking at the period number, you can determine total n of its orbitals, and the total number it has by looking at n, and that are in its orbitals, that total number of orbitals it has, and the total number of, and if we're looking at 3s, then we know that it will have, or if we're looking at just s, it'll have 1 orbital, because the 2 divided by 1 is just going to be, it would just be 1 orbital. And there's 2 electrons for S, and for P there would be 3 orbitals, and for D there would be 5 orbitals, and then F, which you didn't tell us to talk about, but there would be 7 orbitals. And kind of relating back to the shell number, but the energy level, if there's 1 energy level, then it can have 2 electrons max. 2 energy levels is 8 electrons max. 3 energy levels is 18 electrons max, and then plus 3 Ds. And then 4 energy level will have 32 electrons mass plus 4d and 4f in it. And 5 energy level will have 32 electrons mass plus 5d and 5f in it. And how many orientations it has, it relates back. So for D, it has 5 possible orientations for the axis. And for P, there are 3. And for S, there's 1 orientation. And it relates to also, in summary, you can determine the shell number by looking at what period number it's in, and the subshell, the shell number relates to the energy level, and the subshell relates to the shape it'll have for S, P, and D, and also F. And then for the orientation, it tells you what axis it'll be on, and also how many possible orientations it has for it. And it also, for the energy level, you can determine it how many electrons it has max by looking at the energy level. And yeah.